Hello friends, welcome back to my channel Techno Education Academy. In this video lecture, we will discuss the various forces are acting at the time of application of brakes. Here you can see that this is the inertia force, W equal to mg, it is the weight. Okay, it will act on Cg. Cg means center of gravity. The whole weight of the body is concentrated at one point. It is called center of gravity. Okay, and this is the reaction force at a front wheel and rear wheel, and this is the friction force. Okay, F equal to mu r. Okay, we know that, and it will act in opposite direction. Okay, so these are the different forces are acting on the vehicle. The inertia force at the center of the gravity of the vehicle, while the retarding force due to the application of brakes act at the road surface. An overturning couple is formed due to these two forces. This overturning couple increases the perpendicular force between the front wheel and the ground by an amount r, while the perpendicular force between the rear wheels and the ground is decreased by an equal amount. Some of the weight of the vehicle is thus transferred from the rear to the front axle. When the brakes are applied, weight transfer greatly increases the load on the front wheels, while the load on the rear wheels is substantially reduces. This requires the front brake to provide 60 to 80% of the total braking force. To deal with the extra load, the front brakes are much more powerful than the rear brakes. They are able to convert more kinetic energy into heat energy, because we know that whenever we apply the brakes, okay, at that time the kinetic energy will be converted into heat energy due to friction. However, in such a case, the trouble would arise while traveling over the wet road, where high braking efforts at the front would cause skidding of the front wheels. Because of decrease of weight transfer in practice, therefore, about 60% of the braking effort is applied to the front wheels. Let W equal to weight of the vehicle, Rf is the normal reaction at the front wheel, Rr is the normal reaction at the rear wheel, B is the wheelbase. We know that wheelbase means it is the distance between the two axles. Mu is the coefficient of friction between wheels and the road surface, and h is the height of Cg of the vehicle from the surface of the road. Okay, Cg means center of gravity. The whole weight of the body is concentrated at one point. It is called Cg, and you can see that the total weight of the body, it will act on Cg, and alpha is the retardation produced by braking. Now here you can see that the various forces are acting on a vehicle moving down on an inclined slope of an angle theta. Here you can see that theta is the angle of slope. Then inertia force, we know that F equal to ma and W equal to mg. Okay, so m equal to W by g. So put the value of m equal to W by g in equation of force. So inertia force equal to W by g into alpha. Alpha means acceleration, and W by g, here we put the value of mass because W equal to mg, so m equal to W by g. Then braking force at the front wheel. Here we will discuss three cases. Whenever we apply the brakes on front wheel only, whenever we apply the brakes on rear wheel only, and whenever we apply the brake force on all the wheels. So our first case is brake force at the front wheel. So as we know that, okay, friction force means it is act in opposite direction of the motion of the vehicle. This is the motion of the vehicle, and it is the friction force at the front wheel, F equal to mu Rf. Then braking force at the front wheel equal to mu Rf. Okay, as we know that the friction force, it will act in the opposite direction of the motion of the vehicle. This is the motion of the vehicle, and this is the braking force. It will act in opposite direction at front wheel, mu Rf, and braking force at the rear wheel equal to mu R. Consider the system is to be in equilibrium condition. As we know that for equilibrium condition there are three conditions: sigma horizontal equal to 0, sigma vertical equal to 0, and sigma moment equal to 0. So first of all we are considering sigma vertical equal to 0. So here you can see that the forces are acting, okay, vertically in the direction of plane. So RF plus RR, here you can see that these are the two vertical forces in same direction. And here we resolve the component. As we know that which term is making the angle with the reference line, this term is called cos term and remaining term is called sine term. So here you can see that the direction, so here you can see that the weight, it will act on CG. Okay, this is the center of gravity of the vehicle, and weight is always acting downward direction due to gravity. Okay, so the component of W, okay, in y direction is W cos theta, okay, in inclined plane, and W sin theta in the direction of motion. So here you can see that whenever we put the value in sigma vertical, okay, so the one vertical force we are considering W cos theta. Now we are considering sigma horizontal equal to 0. So in the direction of motion of inclined plane, the horizontal forces are mu RF and mu RR. But our case is brakes applied on front wheel only. So here we are considering the friction force on front wheel only. We are not considering the friction force or braking force on rear wheel. So friction force on front wheel equal to mu RF, and in the direction of motion of the vehicle, the two forces we are considering for sigma horizontal, W sin theta and W by G alpha. It is in opposite direction. Now we are taking the moment about point B. Okay, we know that moment means force into perpendicular distance. So at point B, we are considering all forces, okay, which is perpendicular to the different forces. So the first force, inertia force, W by G alpha, its distance is h from this reference line at point B. If you are considering a clockwise moment as a positive, then consider anti-clockwise as a negative, and if you are considering anti-clockwise moment as a positive, then consider clockwise moment as negative. Or you can directly compare, okay, clockwise moment equal to anti-clockwise moment in the system. So here you can see that this inertia force W by G into alpha, okay, its perpendicular distance is h, okay. Then W sin theta, its distance is also h from point B, perpendicular distance is h. And another force W cos theta, okay, here we are considering x distance from the B point, okay, from the center of gravity reference line. Its distance is x from point B. So W cos theta into x, okay, it is the perpendicular distance from point B. Then RF means it is the normal reaction at front wheel, which is perpendicular to the road surface. Okay, so RF into B equal to 0. As I have mentioned, you can consider clockwise moment as a positive, then consider anti-clockwise as a negative, and if you are considering anti-clockwise moment as a positive, then consider clockwise as a negative, or you can directly compare clockwise moment equal to anti-clockwise moment, because here sigma m equal to 0. Continue from the previous equation. Now we substitute the value of RF from equation. Okay, in previous equation we have already derived this equation, mu RF equal to W sin theta plus W by G alpha. Okay, we have derived this equation by sigma horizontal. Okay, so here you can see that RF term is there from this equation. Here we find out the value of RF equal to W by mu sin theta plus W by G into mu alpha, or you can separately common term 1 upon mu in bracket W sin theta plus W by G alpha, and we get, okay, here you can see that B term is already there, here mu term is there, so it is cross multiply with each other, so it is 1 upon mu in bracket W sin theta plus W by G alpha. Okay, here we put the value of RF in this equation. Further, we simplified this term. Here you can see that the W term is common. Okay, so the remaining term is alpha into h by g plus sin theta into h into cos theta into x b by mu in bracket sin theta plus alpha equal to 0. Continue from previous equation. Here we cross multiply the term mu with this term. Okay, so mu alpha into h by g, mu sin theta into h plus mu cos theta into x minus this b term is separately multiply with sin theta and alpha by g, and minus term is there. So minus b sin theta minus alpha upon g into b equal to 0. Here you can see that alpha upon g, it is a common term, alpha upon g, alpha upon g. So minus alpha upon g equal to in bracket b minus mu h. So whenever we multiply minus alpha upon g with b, so we are getting this term, and minus minus plus, then we are getting this term. Okay, and whenever we shift this term, remaining term, from left hand side to right hand side, so it will become negative. So this mu sin theta into h, this is a positive term. Whenever it is shifted, so it will become negative. Same here, mu cos theta into x and minus b sin theta, it is a negative term, so it will become positive whenever it is shifted to right side. Further, we simplified this equation. So here you can see that on right hand side sin theta term is common. Okay, so sin theta, this term is remain as it is. So on right hand side sin theta, it is a common term, b minus mu h minus mu cos theta into x. Continue from previous equation, and here we multiply with minus 1 on both the sides, left hand side and right hand side. So whenever we multiply with minus 1, so this minus minus plus, so it will become positive term, alpha by g b minus mu h. Here it is a minus, so it will become positive because it is multiplied with minus, and this is plus term. So whenever it is multiplied with minus 1, then it is minus sin theta in bracket b minus mu h. So here you can see that b minus mu h on left hand side and right hand side, it is a common term. Okay, so divide by b minus mu h on left hand side and right hand side. So alpha by g equal to mu cos theta into x divided by b minus mu h, and sin theta b minus mu h divided by b minus mu h, so it is cancelled out, the remaining term is sin theta. So it is the equation of alpha by g. Put the value of alpha by g in equation of sigma horizontal equal to 0. We are getting this equation from sigma horizontal equal to 0 in previous slide, mu rf equal to w sin theta plus w by g into alpha. Here we put the value of alpha by g from this equation. So put the value of alpha by g here. We are getting rf equal to wx into cos theta upon b minus mu h. So here you can see that alpha by g equal to this term alpha by g. So here you can see that this is the value of alpha by g. Here we put the value of alpha by g. So here w sin theta, and whenever it is multiplied with w term, so it is minus w sin theta, so it is cancelled out. So we are getting this term, rf equal to wx into cos theta upon b minus mu h. So we are getting the equation of rf, the reaction force at front wheel, equal to wx cos theta upon b minus mu h in previous slide. But we know that sigma vertical equal to rf plus rr equal to w cos theta. So here we put the value of rf, and we are getting the equation of rr. So rf equal to wx cos theta upon b minus mu h. Put the value of rf in the equation of sigma vertical. Further, we simplified this equation, make the object rr. So w cos theta, whenever we shift this term from left hand side to right hand side, then it will become negative term. Further, we simplified this equation by cross multiplication. This b minus mu h, it is multiplied with w cos theta, and we are getting this equation. And this is the value of reaction force at RR, or equation of reaction force at rear wheel. Now we are considering the brakes are applied on rear wheel only. Okay, so whenever the brakes are applied on rear wheel, at that time we are considering the friction force on braking force on rear wheel only. We are not considering the braking force at front wheel. Again, resolving the forces, we get sigma vertical forces Rf plus Rr equal to W cos theta. It will remain same as it is. In horizontal forces equation, we are considering mu Rr instead of mu Rf, because it is the case of brakes applied on rear wheel only. So we are considering the braking force for rear wheel. So mu Rr, it is the horizontal force in the inclined surface. We are not considering this force because the forces brakes are applied on rear wheel only. And W sin theta and W by G alpha, okay, inertia force we are considering. Now taking the moment at point A, here we are considering all the forces, okay, which is perpendicular from point A. So taking moment at point A, so at RF, the same line of action, so distance is 0. So RF into 0 we are not considering. So W by G into alpha, its distance is h, perpendicular, plus W sin theta into distance is perpendicular distance is h, and RB into B. Here you can see that at point A, whenever we are taking the moment, so the force which is perpendicular RR, its distance is B, okay, RR into B, and W cos theta into B minus X. This is total B and this is X, so the remaining term is B minus X equal to 0. Continue from previous equation. Substituting the value of RR from equation, mu RR equal to W sin theta plus W by G alpha. Make the object RR. Okay, so RR equal to 1 upon mu in bracket W sin theta plus W by G alpha. So put the value of RR in this equation and we are getting this equation. Okay, this term is remain as it is up to this, and here we put the value of RR equal to 1 upon mu in bracket W sin theta plus W by G alpha. Further, we simplified this equation, and whenever we cross multiply mu with this term, and we are getting this equation. You can derive this equation same as whatever we derived in previous slide. Now we will put the value of alpha by G in this equation. Okay, sigma horizontal. You can derive this equation by the same procedure we follow it in previous slide by cross multiplication, and simply put the value of alpha by G in this equation. Okay, and it is multiplied with this term, so minus W sin theta plus W sin theta, so it is cancelled out. So the remaining term RR equal to W B minus X cos theta upon B plus mu H. Now we will put the value of RR in equation of sigma vertical equal to 0, RF plus RR equal to W cos theta. Here we put the value of RR in this equation and we are getting the value of RF. So RF equal to W in bracket X plus mu H cos theta upon B plus mu H. Now we are considering the third case, brakes applied on all the wheels. So resolving the forces, we get sigma vertical equal to 0. So here we are considering the vertical forces RF plus RR in the same direction and W cos theta in opposite direction. So RF plus RR equal to W cos theta. Now we are considering sigma horizontal equal to 0. So here we applied the brakes on all the wheels. So here we are considering braking force mu RF and mu RR both. Okay, in previous case, whenever we are considering the brakes applied on front wheel, so we are considering only braking force on front wheel mu RF. Whenever we are considering the brakes applied on rear wheel only, so we are considering the braking force mu RR only. At that time we are not considering this force. But in this case, the brakes applied on all the wheels, so we are considering mu RF as well as mu RR. and two other force which is in opposite direction or in the direction of motion of vehicle. W sin theta, which is the component of W, okay, in the direction of motion of vehicle, and it is inertia force W by G alpha, as we know that F equal to ma and W equal to mg, so m equal to W by G into alpha. Now we will put the value of Rf plus Rr in this equation. Here you can see that mu term is common, okay, and Rf plus Rr, we will put the value of Rf plus Rr equal to W cos theta. So mu into W cos theta equal to W sin theta plus W by G alpha. So alpha by G, here you can see that W term is common, so it is cancelled out from left hand side and right hand side. And whenever we make the object alpha by G, so alpha by G equal to mu cos theta, and whenever we shift W sin theta from right hand side to left hand side, so it will become negative minus sin theta. So this is the value of alpha by G equal to mu cos theta minus sin theta. Now we are taking the moment at point A. You can take moment at any point A or B for getting the value of Rf and Rr. Here we are taking the moment at point A. So moment means force into perpendicular distance. So we are considering all the forces, okay, which is perpendicular to the line of action of at point A. So the first force, inertia force W by G into alpha, its distance is h from the line of action of A. So W by G alpha, its distance is h. Then second force W sin theta, its distance is also h. The other force RB, reaction force at rear wheel, its distance is B, which is perpendicular from line of action of A, and Rf into 0 because its distance is 0. Okay, for moment we are required perpendicular distance. For moment we required perpendicular distance, but here this Rf, it will act in same line of action, so its distance is 0. So Rf into 0, so we are not considering it. Okay, and W cos theta, okay, it is the vertical component of W. W cos theta, its distance is B minus x. This is total B and this is x, so the remaining term is B minus x, okay, which is the perpendicular distance of W cos theta at point A equal to 0. So in this equation, we will put the value of alpha by G equal to mu cos theta minus sin theta. So here you can see that alpha by G term is there. Here we will put the value of alpha by G, and the WH term is also there. So WH into mu cos theta, WH into sin theta, and this term is remain as it is, W sin theta into H plus RB into B minus W cos theta into B minus X equal to 0. So in this equation here you can see that minus WH sin theta and plus WH sin theta, it is cancel out. And whenever we make the object RR, and further we simplified this equation and we are getting the value of RR. So RR equal to W in bracket B minus X minus mu H cos theta divided by B. And whenever we put the value in equation of sigma vertical, Rf equal to W in bracket X plus mu H cos theta divided by B. So this is the equation of forces for different condition of brakes applied on the wheels. Thank you friends for watching this video. I hope this content it will be helpful to you. If you would like to watch this type of more technical videos, then please subscribe our channel and also share with your friends.